This question had appeared in JEE Mains 2018. Phenol reacts with methyl chloroformate in the presence of NaOH to form product A. A reacts with Br2 to form product B. We have to identify A and B respectively. So there are four options being given. Let's write down the reaction in words. Phenol is reacting with methyl chloroformate in the presence of sodium hydroxide to give product A, and product A reacts with bromine to give product B. We have to identify A and B. Let's draw the structure of phenol. This is the structure of phenol. Then let's take methyl chloroformate. Formic acid is H, C double bond O, single bond OH. It's methyl, so here we put a methyl. Chloroformate, so here we put a Cl bond Cl. This is known as methyl chloroformate. In the presence of sodium hydroxide, we can remove this hydrogen along with this chlorine so that we get the formation of a compound here, which is our compound A. Let's draw this compound A. Double bond O. Then we have a single bond OCH3. I have simply bonded this oxygen is over here. Then COOCH3 is bonded onto the oxygen atom so that we get the formation of this compound A. Now let's check the options. See, the first one is out of question because here OH is there, still there. So we can be having either B or C. Even option D is out of question. Now we have to simply identify where bromine is going to attack. This is the meta position or at the para position. Now normally the attack takes place at the positions where we are having high electron density. So let's find out where we can be having high electron density. Let's take this compound here. Now when we are taking this compound, observe, we can be having cross conjugation. Let's number the oxygen atoms here. This is the oxygen atom number 1 and this is the oxygen atom number 2. Now the oxygen atom number 1 is the only one which is available to the ring. So to this ring, oxygen atom number 1 is available. I mean to say the lone pairs of oxygen atom number 1 are available, so that we can be having resonating structures. So let's try to draw the resonating structures here. The lone pair will shift in between the oxygen atom and the carbon atom so that we can show the shift in the next structure like this. Here we have the double bond and this oxygen will develop a positive charge. The electron density on the carbon atom increases and therefore the bonding pair will shift and get localized as a lone pair, and that can be shown in structure number 2. Let's remove this. Next structure, the lone pair which is localized at the ortho position will be shifting in between the next two carbons as a bond pair. Let's show the shift on structure number 3. The electron density structure number 2 is increasing on this carbon atom So let's shift the bond pair onto the next carbon atom so that it becomes a lone pair here. Let's draw the next structure, structure number 4. Now the lone pair will shift once again between the next two carbon atoms. Let's show the change in structure number 4. So here we'll be having the lone pair getting converted into the bond pair. Now the electron density in structure number 3 at this red carbon increases. So the bond pair will shift onto the next carbon atom as a lone pair. Let's draw the last structure here. Now the lone pair will shift in between the next two carbon atoms. Show the change in structure number 5. So that the bonding pair on between the oxygen and the carbon will shift onto the oxygen atom and once again become a lone pair. If you carefully observe structure number 1 and structure number 5, you will see that the structure is almost the same, only the bonds between the carbons have shifted. Observe one more thing, which is the most important one rather, the position of the lone pair. Ortho, ortho and para position. That means the position number 2, 4 and 6. So we can be having the attack of bromine atom either at position 2 or position 4 or position 6. Let's try this. Take compound A and treat it with Br2. If Br tries to attack at ortho positions, that is 2 and 6, there is a lot of steric hindrance because this group is quite a bulky group. So Br won't attack at the ortho positions, rather it will be attacking the para position because it will be much more stable if it is at the para position. And we will have minus HBr. So this is our compound B. Let's have a look at the options. So meta position won't be the answer. Para position attack of bromine will be the answer. So the answer for this question is option number C. Thank you.